Hello there! In this tutorial, we are going to cover decorators, which are a somewhat more advanced topic in Python. So let's go over some theory first. In the most basic sense, decorators are functions that decorate other functions, which does sound a bit cryptic, but essentially what we do is we are wrapping one function around another function. And let's do this a bit more visually to illustrate what's happening. This is a normal function, and usually what you do is you just call it somewhere and then you have something happening. What decorators do is we still have the normal function, but now we are putting another function around it. And then when we are calling all of this, we are calling the decorator function, and inside of that decorator function, we are calling the original function. And this is allowing us to execute code before and after the function. So when I'm calling this function here, I could run code here and I could run code here without making any changes to the original function. This function here would stay exactly the same. All the actual logic happens inside of the decorator. We are literally putting one function inside of another function, and this other function executes extra code. That's the entire idea of a decorator. Now, why would you want to do this? Basically, this way we can give extra functionality to a function without changing it. A simple example here is we could write a decorator for a function and it makes the function execute twice when called. Not the most useful function, but we are going to talk some more useful examples later on. I just want to illustrate what is happening. Now, in practice, you are seeing decorators in 3 different circumstances. Let's go over them. The most common one is you want to test your code without changing it. Let's say you work in a team, you have some really complicated code, and you want to test your code without making too many changes. A decorator would be excellent for that. The other example would be you are working in a team and you want to avoid making unnecessary changes. Now, those 2 points are pretty similar. You basically want to do something with your code without making too many changes. And both of these are also fairly advanced. If you are just learning Python, you are quite far away from either of these, which is why you may be struggling with decorators, because you don't really need them. However, there is a third case that you probably are going to use, and that is using a decorator inside of a class, because this allows you to run code when an attribute is accessed or changed. So for example, let's say you have a monster with health, and every time that health is changed, you want to run some other function inside of the monster. With a decorator, doing this is fairly easy. Although, that being said, decorators can be quite hard, especially for beginners, because we are going to use some more advanced functionalities in Python that may be slightly confusing. Although, I would really recommend you to try to follow along, because this is going to be really good practice to understand functions and how to pass them around. In fact, before we start with decorators, we need to recap functions itself. So let's have a look at that. Here we have a completely empty sheet of code. And let's just get started with a really basic function. I want to define, let's call it func, there are no arguments. And inside of this function, I just want to print function. Just about the easiest function you can write. If I call this function, I get function. So this really doesn't do all that much. Now there's a really important concept you have to understand, that right now we are calling the function here. And if we didn't do that, so if I remove those brackets, I could run this and nothing would happen. But what I could do is print the function itself, and now I get a function object, meaning this function here as the whole function, not what's being returned, just the function itself. And this is just going to be an object. If that doesn't tell you anything, check out my videos on object-oriented programming. They should be quite helpful. But basically, what this func is giving us is a simple object that we can call. And if we don't call it, we are just getting a function object. Still not particularly useful. But what we can do with this function object is pass it around like any other object, like an integer, like a string, like basically any other object. We can pass it around. For example, what we can do, I can create another function, and this, let's call it a wrapper, because this one is supposed to take the argument of the function, and then I want to execute the function itself. Meaning what I can do now, I can call my wrapper function and run this, and I get function again. And what is happening in here? I am calling this wrapper and I'm passing in this function here. What happens as a consequence is this function is being passed as a parameter into the wrapper function, and inside of that function, we are calling this function. And when we are calling it, we are printing the word function. And now that we have that, we could also do something like print hello and print goodbye. And if I run this now, we are running the function inside of another function, and before and after we are calling it, we are running some other code. And this is basically the main idea of a decorator, although it does get a bit more complicated. But we'll come to that in just a bit. Now, there's one more thing that you can do inside of a function, and that is you can create a whole new function. So, for example, let me create another function. And let's call this one a function generator. And in here, we have no arguments to keep it simple. And now inside of this function generator, I want to create a new function. And let's call this one new function, I guess is a good word. And in here, I just want to print new function. And since this new function is just going to be an object, we can return the new function. And what I can do with that, I can create a variable, let's call it new function, and I want to get my function generator, and if I run this, we can't see anything. But now this new function is going to have this new function in here. Meaning what I can do, I can call my new function, execute it, and we get new function. So just to go over this, because it may be a bit confusing, this new function executes this one here. And what we are getting from this function generator is we are defining a new function, this one here. And at the end of the function, we are returning this new function. And this we are capturing inside of this new function variable. And this new function variable now is just a function, meaning we can call it here. And when we are calling it, we are getting this print statement. That's really all that's happening here. The main thing you have to understand is we are basically passing around functions with the return statement. With that, we have some function basics, so now we can actually start working on the decorator. And for that, let me open up a new file. And in here, I want to create an actual decorator. Now, first of all, for a decorator, we are going to need a basic function we want to decorate. So from my function basics, I want to copy this basic function here, which is just printing function by itself. So if I run this, we get function. Literally the easiest function you can write, more or less. And now for this function, I want to create a decorator. And this is going to be another function that you can give whatever name you want. Let's say I want to call this one decorator to keep things simple. And this decorator is going to accept one parameter, which is going to be a function. So in just a bit, we're going to pass this function inside of this decorator. What we are going to do with that, inside of this function, we are going to create another function. And let's call this one the wrapper. And this one right now doesn't have any arguments. But now inside of this function, I want to run the original function. And besides that, I can do quite a few other things. For example, I could just print the decoration begins, and let me write this properly. And I can also write the decoration ends. And now after I have done that, I can return this wrapper. And now what I can do, I can create my new function. And this is going to be my decorator. And inside of this decorator, I want to pass in my function. And once I have that, I can just call my new function, and I get the decorator begins, the function, and the decorator ends. What is happening here? Let me go over this. This is probably a bit confusing. We are starting with our basic function. And this function we are passing in here into the decorator function. And this is the one we have up here. And inside of this decorator function, we are creating a whole new function, this bit here. And inside of this function, we are calling the original function, meaning this one here. And then around this function, we are doing some other stuff, like we are printing these two statements here. And then at the end of all of this, we are returning this new function, and this new function we are storing in the new function variable. And then we can just call it like any other function, and now we have extra functionality around our original function. Now, where this becomes really interesting is, let's say, somewhere later in the course, I am running function by itself, which would just give me the word function. Let me comment out these two lines here. If I just run func, I get function and nothing else. And what I can do with decorators, if I uncomment those two lines and get rid of this new func, when I create the variable name for this, I can just call it the same way like I have called the original function. So I can call both func. If I do that and run the code again, I now have a new functionality for this function, because we are essentially overwriting the original function name, and that way our function, even with the same name, has new functionality. And this is the basic idea of a decorator. If we have this kind of system, we can have really complex code and still check our function without making any changes to the code. And since this is a reasonable common operation, Python has a shorthand for it. And let me comment out this statement here. And the shorthand looks like this. I first write an add and then the decorator function. So in this case, decorator. And now if I run all of this again, we are seeing the same outcome. For the simple reason, let me uncomment it, that this statement here and this line here, they are doing essentially the same thing. We are wrapping this function here inside of a decorator, this one here. And let's go over this a bit more slowly. I think that's going to be useful. Here we have the function you have just seen. And you can wrap this in the traditional way by writing the function, and then we are putting the function inside of the decorator, and then we are calling the function. I hope this is making sense. If you're confused about this, I would recommend to pause the video now and just go over all of these different statements and see how they connect. I guess I can go over it as well. Again, we have this decorator here, and inside of this decorator, we are passing in the function. And then we get this function here as a parameter. Now, inside of this function, we are creating a whole new function. And this one is called wrapper. And only inside of this function, we are calling the original function, this one here. And then around this function, we can do whatever we want, like calling these two print statements here. We could also do lots of other things. I'm going to cover that in just a second. And finally, at the end, what we are doing is we are returning this wrapper function. And this wrapper function, we are storing right now in func, and then we can call it like any other function. And that way, we are using the name of the function and overwrite it with this new function that is being wrapped inside of the function. Which means if I took out this line here, the function would come back to its original functionality and just print function. Now the problem with that approach is that we are writing func 3 times, 1, 2, and 3, and if we want to call it a 4th time, which is kind of annoying. So what Python developers have done is to create a shorthand for this, and this is called a decorator. And this one is looking like this. And basically this line here, where we have the name of the function, a decorator, and then the function as an argument, is the same as this add decorator. Those two lines are doing the exact same thing. Meaning when you are calling this function, you have the same result. Now, obviously, just printing 2 more statements isn't particularly useful. So let's actually do something more relevant to see why decorators can be useful. Here we are back in the code, and I want to create another decorator. And this one I want to call the duration decorator. And then here, again, as a parameter, we need the function. And inside of that, I want to create a wrapper. Doesn't need any arguments. And in here, first of all, I want to execute my function and then return the wrapper. And this is essentially a decorator that doesn't do anything right now. And what I want to do with it is to measure how long it takes to execute this function here. And for that to work, we need the time module, meaning I want to import time. And now what I want to do inside of this decorator, I want to get my start time, and this I would get with time.time. And this has to run before I call the function. And after I have called the function, I want to get my duration, and my duration is my time.time, which is my current time. And from that, I want to subtract my start time. And once I have that, I can print, let's call it duration, and this should be an f string with the duration. And now, just to get some reasonable numbers in here, when I am calling the original function, I want to call time.sleep and make it sleep for 1 second. And now, with this duration decorator, let me actually call it, so duration decorator. I can now comment out this line here, and now if I run the code, we get function, and we get the actual duration. And from this line, we know it took 1 point, a tiny amount of time to execute all of this. And this now we could get without making any changes anywhere else in the code. We're just calling the function here, we have the wrapper up here, and then we're adding this 1 line of code to add some debugging functionality. So this is something you could be doing if your code is running very slow and you want to identify what is slowing it down. Now, another thing that I haven't covered yet is that you can combine different decorators. And this happens by just adding them with the different add statements on top of each other. And we already have another decorator. So let me call this original decorator, and let's run all of this again. And now let me go through them. I have decorator begins and decorator ends. That is what we are getting up here from this original decorator. Besides that, we have the duration of the decorator. And this is what we are getting from this print statement here. And the actual function, so this print here, is this line. Meaning now, even though we have a very simple function, by using decorators, we can give it a ton more extra functionality without making any changes to it. Which is, well, the entire idea of a decorator. If you understand this, it can be really useful in very specific circumstances. Although, if you are a beginner, you probably just are going to add more stuff to this function. Although, well, if you know decorators, you don't have to. And this makes it much cleaner to work with your functions. But alright, let's do another exercise on this. I want you guys to create another decorator that calls a function twice. And this decorator should be called with this decorator and this decorator as well, so that this function has 3 decorators in total. And let's see how far you get. Again, I have to create another function, and let's call it the double decorator. And in here, once more, we need a function, And inside of this function, I want to create a wrapper. Doesn't need any arguments again. And now in here, I want to call my function twice, which I just do by calling my function twice. It's very simple once it comes down to it. And once I have that, I want to return the wrapper once more. Oh, and by the way, I'm just calling this wrapper because I think it makes sense. You could call this whatever you want, there's no naming restriction. And alright, now what I can do, I can add another decorator with the double decorator. And now if I run all of this, we have to wait a second. And if I expand this, we have the code being executed once and then twice. And well, this is working really nicely. And here again, our actual function is really simple. And we are just adding more and more stuff to it. And that way it gets more and more complex. With that, we have some very basic decorators. Now, there are some more things we can do with them. And what I want to cover for this part is that you can have functions with parameters being decorated. That part is actually really simple. And besides that, decorators themselves can also have parameters. Although implementing this gets even more complicated because we are wrapping a function inside of a function inside of another function. So this we will have to explore in quite some more detail. But let's have a look at all of this. Here I am back in a completely empty sheet of code, and I want to create a new function. So define function, and now I want to have a function parameter. Doesn't really matter what it is, and in my case, I am just going to print that function parameter. And now once we have that, I can call this function with whatever I want, let's say hello, and if I run this, I get hello, a super simple function. And to decorate this, we kind of need the same thing we have done here. It's not really that much more complicated. As a matter of fact, let me actually copy this decorator here and paste it in here. And now I want to decorate this function with the decorator. And just as a reminder, this would be the same thing as calling function is the decorator with the function. However, now if I call this, I am getting the decorator takes 0 positional arguments, but 1 was given. And this happens in this one as well as in this one. So we're getting the same error message. That's usually a good sign at the very least. The problem Python has is that this function needs this parameter. So when we are calling the function up here, we again need the parameter. But on top of that, when we call this function here, we are calling this wrapper. And right now, when we are calling hello, we are passing it essentially into this parameter here, which doesn't exist yet, which is why Python is so unhappy. And to get around this, we just have to create the parameters, meaning this wrapper here and this function need the same parameters. Or well, for this wrapper, it's a parameter. For this function, it's an argument. And let me name them properly here. I want to have a wrapper parameter. And now if I run all of this again, we should see a different error message. And that is that func is missing one required positional argument, func parameter, meaning this one here. And well, I get this argument from the wrapper parameter. So now if I run this, we get hello. And if I change this argument to something, this is still working. And we could also do this the other way, the more traditional way, and we will get the same outcome. And let me just go over what is happening here by using the traditional style to make it a bit easier to explain. We are again calling this decorator function here and passing in the function itself. Now, inside of this decorator, we are creating all of this here. And right now, the wrapper has one parameter, the wrapper parameter. And then inside of this wrapper function, we are calling whatever code we want. And we also have the original function here. And then we are passing the wrapper parameter as an argument inside of this function. And once we have all of that, at the end of the code, we can just call the function with something, and then this something would be passed into the parameter for the wrapper, and then this would be passed into the original function. Now, what you see very often, for the wrapper, you don't have one specific argument. Instead, people very often just add arcs with a star and then double quarks. And then this you pass into whatever original function you have. So if I run this, we get the same outcome. And these are very simple unpacking operators. This one is for a list, and this one is for a dictionary or keywords. And the reason why these are used is because they allow for this decorator to accept basically any kind of function with any kind of parameter. Right now, we only have one parameter, but we could also have more named parameters and an unlimited amount of arguments. It doesn't really matter. If you have this setup, you can accept any number of arguments or named arguments, which means that this decorator works with literally any function without limitation. And alright, with that, we have basic parameters. What we can also do, let me uncomment the decorator. Let's try if this is working. It does. What we can also do is create a decorator that is accepting other arguments, like a 10, for example. But for that to work, we need something even more complex. So let's do this in a separate file. All right, and here once more, we have an incredibly simple function. If I call this function, we can see function. And now what I want to do. I want to create another decorator, and let's call this one a repetition decorator. And this one should accept one argument by how many times I want to repeat this function here. For example, if I add a 5 in here, I want to repeat this code 5 times when it's being called. Or rather, I want to call it 5 times when it is being called. Now, for that to work, we need some pretty extensive setup. And let me go through how this would look like. I am first going to create the actual decorator, so repetition decorator. But this one is not going to accept a function. Instead, it is going to accept this argument here. So in my case, I want to call this the repetitions. And now inside of this, I am creating another function, and this is the actual decorator. And this decorator is going to accept a function. And now inside of this decorator, I want to create the actual wrapper. And this one, in my case, has no arguments. And what I want to do is for, let's call it R in range repetitions, I want to run my function. And now what I have to do, I have to, inside of the decorator, I want to return the wrapper. And then inside of the scope of this repetition decorator, I want to return the actual decorator. And now if I run this, it is going to work 5 times. And I can change this to a 20, and we will call this function 20 times. Now the question is, why does this work? So let's go over it, and let's do this in a traditional way, which I guess I haven't done yet. But if we didn't use decorators and still wanted to use this, it would look like this. I'm still using my func variable name, and now I want to call the repetition decorator. And now for this repetition decorator, I have to specify how many repetitions I want. Let's say 4 in this case. And after I have that, I am calling whatever I get from this and passing in my function. And if I run this, we get function 4 times. Now, if you look at this, this is probably really confusing. But to understand this, you basically have to understand the return statement. And let's go through it one by one. First of all, we are calling the repetition decorator and passing in 4. That is this line of code here. And this one by itself doesn't actually do all that much. All we are doing is creating a new function and returning it. So all we are getting from this repetition decorator with a for is this decorator here, a new function. Meaning this decorator here is going to replace the entire decorator we have seen so far. And on this new decorator, we are calling the new function, this one here. Meaning now we are passing this function inside of here, and this function is being captured inside of this parameter. And once we have that, we are basically back to a normal decorator. So inside of this decorator, we have a wrapper, and this one just loops over the range of repetitions that we get from up here. And then inside of that, we are calling the function, and then we are returning the wrapper. And then this wrapper is being stored inside of the function, and we can call this function, and then we are repeating it by whatever we specified in here. And well, if I comment this out again and return to my decorator, let's add 4 in here, and we still get 4 repetitions. And I would really recommend you to practice this in your own time. Although if you're just starting, don't worry too much about it. Just get used to functions and classes by themselves, and once you are a bit more comfortable, start working on decorators. They are definitely one of the more advanced topics in Python. Although there is going to be another section, and this is where you are probably going to use decorators the most as a beginner. And that is to use decorators inside of classes. So let's talk about decorators inside of classes. And there's one really important one. It is called property. And what this allows us to do is it allows us to turn methods into attributes. And this is something we get from the property function that we can use inside of Python. It actually comes with Python. And I'm pretty sure all of this is going to sound really cryptic if I just explain it theoretically. So let's do all of this in code. That should be better. All right, here I have a completely empty Python file. And what I want to do is to create a new class. Let's call it generic. And in here, I want to create a dunder init method. And this one needs self and nothing else. And what I want to do in here is create one attribute, let's call it x, and let's set a value for 10. It really doesn't matter what it is. And now I want to create an object from this class. Let's call it generic, and I just want my generic class. And now I can print generic.x, and I should get 10, and indeed I do. And now what I want to do is I want to observe this x here. Meaning whenever I look at it, so I retrieve the value, or when I change the value, I want to run some other code. And this by itself in Python isn't really that easy to do. I guess what you could be doing is run some kind of function that, let's call it getX, in here self, and in here I could return self.x, and then besides that I could print some other code, let's say getX. And now inside of this print statement, instead of x, I want to get x. And don't forget to call it. If I run this, I get x and the value. So when I get x, I can run some other code. And this is fine by itself, but it's not very elegant. And again, like we have seen with the other decorators, what happens if I already have a lot of code? Let's say I have this generic x 10 times in my code, and I don't want to change all of these instances here. I just want to change my class itself to account for that. That whenever we get x, I want to run some other code. And this we can do, but we need some special function in Python. And this function is called property. And into this property function, we can pass in a getter, a setter, and a deleter. And then we can assign all of this to one attribute inside of our class. Let's say x right now. And then this x is what we are actually going to work with. So now when we are calling generic x, this line here, this x refers to this x here. And then when we are just looking at this x, we are calling the getter method. When we are changing this x, we are calling setter. And when we are deleting this x, we are calling deleter. Meaning now what you usually see with this, the original attribute we have, this x here, we are turning into a private method with an underscore before it. And now to Python, this x here and this x are two separate variables. But I, as a programmer, still know that they're the same because of the naming convention here. And now basically what I'm going to do, for this getter, I am going to return _x. And with that, we have a getter. So this method here is going to be this getter, meaning whenever we are calling this generic x, we are calling this getter method, which is then returning this _x. And essentially what we are doing here, outside of the class, we are working with x, and this is what we are accessing. But inside of the class, we are using _x, and this is what actually keeps track of the value. And now, basically what we have to do, besides the getter, we also need a setter. So let me change it. And for the setter, we need self and a new value. And when we are calling this, let me run set x, and then self _x should be the value. And this we do not want to return. And finally, besides that, let me copy it one more time. I want to have a deleter. This one doesn't need a value. And what I want to do in here is delete x. And all we have to do for this one is to run del and self._x. And now I can run this. And let me make this a bit smaller. Now, when I print generic x, we get getX and the value of x, meaning we have run this method here. What I can also do before I'm printing x, I can run generic x is equal to 4. And now if I run this, I am setting x and I'm getting x, and then I get the actual value of x. And finally, what I can do, I can also run delete and generic.x. And now if I run this, I have set x, get x, the value of x, and delete x. Meaning now, whenever I, for example, get the value of x, I can run whatever other code I want. And for example, what I could do with that, I could import from datetime, that's not how you spell that, from datetime import datetime. And I want to know whenever I get x, which I get by just printing the datetime.now. And now if I run this, I am getting the current time when I'm accessing x. And since we're just returning this _x, you could even make changes to whatever x you get, depending on the time of day, some other variables, basically anything you want to look at. Which is why all of this is really powerful. And I would recommend to go over this in your own time. It's really useful. But just to go over it really quickly again, I think that's going to be useful. When we are initiating this class, we have _x, this one here. And this is the variable we actually storing values in. Right now that is 10, but it really doesn't matter what it is. Once we have that, we are running this line here, and this one turns x into a property. And this property has a getter, a setter, and a deleter. And those are referring to this getter here, this setter here, and this deleter. And now from outside of the class, whenever we are accessing this x here, we are running either of these methods. And these methods then influence self.x. which is where we actually store the value. So this one here. And that way, when we are accessing, changing, or deleting a value, we can run whatever other code we want in there. And I hope this is making sense. This is, again, something slightly more advanced that you probably want to practice on your own time. But what Python developers also realized is that this isn't exactly an elegant way of writing all of this, which is why this property works really well as a decorator. And let me copy the entire class to implement this as a decorator. And let me comment out all of this. And basically, how you would implement all of this as a decorator. For the getter, you would simply add the add property decorator. Although then the getter, you would rename to the name of the property, which in my case is this one here. So I just want this to be X. Now for the setter, I want to get another decorator, and this one you would call with the name of the property, in my case again X, and now you would add dot setter. And then the actual method would also be called X, or the name of the property. And finally, the same works for deleter, so we need x.deleter. And now the name of the method should also be the name of the property. So X in my case. And now once we have that, I can get rid of this property here. And now this code does the same as this code up here. Meaning if I run all of this, we get the exact same result, except now it's a bit easier to read, I suppose. And this is something you are going to see reasonably often, even as a beginner, because running some code when you're just changing a value, or even when you're just looking at the value, can be really powerful. So understanding this here, or at least being able to replicate it by yourself, is going to be something you do want to practice. But again, this is all very advanced, so if you're just learning Python and all of this is too much, don't worry about it. You are not going to use it for quite some time, and it would be much more valuable for you to understand classes and functions by themselves. So don't stress yourself if this is too much. But anyway, this is all you need to know to get started with decorators, and I hope that was helpful.